So for this lesson of basic calculus course, we'll be discussing the derivatives of algebraic and exponential functions. So let us start with some definition first. Differentiation and the derivative. The study of calculus usually begins with the basic definition of a derivative. A derivative is obtained through the process of differentiation. The study of all forms of differentiation is collectively referred to as differential calculus. So our subject here is differential calculus. So to compare derivative and differentiation. So hold on. So the differentiation is the process. So it is the process. So when we do differentiation, we get an answer. So that is called the derivative. So differentiation is the process and the answer is the derivative. So here in basic calculus, we will be hearing terms like derivative, slope, and rate of change. As a matter of fact, derivative, slope, and rate of change are the same. So derivatives that in calculus lesson or equations, which is equivalent to slope or rate of change at a given point, while slope is the term we use in rate of change is the term used in worded problems. So derivative, slope, and rate of change means the same. We just use different terms for different scenarios. For example, so we use derivative in differential calculus equation. For example, we have y is equal to 5x plus 10, for example. Then, if you get the derivative of this, you should write the notation of y prime for the derivative. Or you can also write dy all over dx for the derivative. Y here is this one, so the dependent variable, and x here is the dx here. So if you're given, for example, y is equal to 5r plus 2, then you can also write here the derivative as y prime, but for another notation that would be dy all over dr, because here your variable is r. Another one, we can express function as f of x. For example, f of x equal to 6x squared plus 10. Here you can write the derivative as f prime of x. So basically, y prime and f of x are the same, so you can just use it depending on your given. Okay? Another, so slope at a given point. So derivative and slope at a given point means the same, but slope at a given point, we use it in graphical representation. For example, we have a graph, something like this. A graph, something like this, okay? So now, at different points here, we have different slopes. For example, let me put 4 points here. So to estimate the slope, we can draw tangent lines here. So to estimate the slope here, we can draw a tangent line like that. And here, tangent line, and here, tangent line. So these tangent lines is the representation of slope. So slope values can be positive or negative. So if the slope leans to the right, then the slope is positive. It leans to the right. So this one is also positive. If the tangent line leans to the left, then the slope value is negative. So if the tangent line is horizontal, then the slope is 0. Okay, so if it leans to the right, then it's positive. Leans to the left, negative. And if it leans to if it's horizontal, then it is 0. So you will have an idea if the given slope is positive or negative depending on the tangent line that you draw. So another one is the rate of change. So derivative, slope, and rate of change means the same, but rate of change, you will mostly hear it during worded problems. For example, in worded problems, you will hear such thing as how fast is the water rising, something like that. So this means rate of change. So how fast is the water rising? So how slow is the snail moving? So this means rate of change. So how fast or how slow means rate of change. So you will hear rate of change mostly in worded problems, but derivative, slope, and rate of change just means the same. We just use it in different scenarios. Okay, I hope you understand that. Because we would like to emphasize here that when you are solving for derivative, you are effectively solving for a slope or rate of change. So that is very important in most problems. Okay, so let us now go to some derivative or differentiation formulas. So we have a lot of different derivative formulas, but all of this came from the increment method from previous modules. So, but these formulas are the shortcut or the formulas that we can use easily. So, derivative number one, the derivative of a constant. So, if you if you find the derivative of a constant, then the answer is always 0. So, for example, y is equal to 5. So if y is equal to 5, then 5 is a constant, then y prime, the derivative, is only equal to 0. For example, another, if you have f of x is equal to negative 3. So if f of x is equal to negative 3 and negative 3 is a constant, then the derivative f prime x is equal to only 0. So if you're only seeing a constant, then the derivative is always 0. For example, y is equal to 70. Then you can say that dy all over dx is equal to 0 only. So another f of x, if f of x equal to negative 1 half, then f prime of x is only equal to 0. So if you're only seeing constant to be differentiated, and then therefore the answer is always 0. The derivative of a constant is 0. So I'm hoping that is clear. Okay. Number 2, derivative of x raised to n. So this is the derivative of a variable raised to an exponent. So the derivative is n x raised to n minus 1. For example, y is equal to x raised to 6. So here, the n is equal to 6. So therefore, our y prime is equal to, so we just follow this formula. So n is equal to 6. So 6x, then 6 minus 1, then y prime is equal to 6x raised to 5. Another example is that, if, for example, we have f of x is equal to x raised to 10. So n here is equal to 10. Therefore, f prime of x is equal to, so we just follow the formula, 10x. So 10 minus 1 is equal to 9. So maybe we can have another example. F of x is equal to x raised to negative 7. So n here is -7. So therefore, f prime of x equal to, follow the formula, so -7 x -7 minus 1, so is equal to -7 x raised to -8, since -1 minus 1 is equal to -8. So this is your derivative. So I'm hoping that is clear, okay? That is for derivative number 2. For derivative number 3, derivative of a variable with a constant. So we will just combine the two earlier. So the derivative of a variable with a constant is equal to the constant, then the derivative of the variable. For example, y is equal to 5x raised to 4. So in this formula, you will notice that you will just separate the constant. So the constant here is this one, C, and this is your U. So C and U. So therefore, the derivative of this is y prime is equal to C. Your C would be 5, and the derivative of U. So the derivative of U earlier is, that would be 4x raised to 4 minus 1. So this is the derivative earlier for derivative number 2. Then y prime is equal to 20 x raised to 3. Okay? So another example, for example, we have 5x of f of x is equal to 7 x raised to 9. So the derivative of this, f prime x equal to, so you just separate the 7, then get the derivative of this one. So the derivative of that is 9x raised to 9 minus 1. So this is equal to 63x raised to 8. So maybe we can have another example here. For example, f of x is equal to 10x. So here we will just separate the 10, f prime x equal to 10, then get the derivative of x. So x equal to, so this is equal raised to 1, 1 minus 1. So f prime x is equal to 10x raised to 0. So anything raised to 0 is equal to 1. So therefore, f prime x is equal to just 10. So another example, y is equal to negative 4x raised to 8. So y prime of this, or the derivative, is equal to negative 4. Then find the derivative of this one. So that would be 8x 8 minus 1. Then y prime is equal to negative 32, because negative 4 times 8 is negative 32. Then x raised to 7. So these are your derivatives. I'm hoping that is clear. Okay. Next, derivative. So the derivative with addition or subtraction. So the derivative of addition with subtraction is just the derivative of both terms. For example, y is equal to x cubed plus 5. So this is an addition of x cubed and 5. So when we get the derivative of this, y prime, so we just get the derivative of this. So 3x squared, then the derivative of 5 is 0 because it is a constant. So y prime is equal to 3x squared. Another, f of x is equal to 4x raised to 4 plus 5x. So if we get the derivative of 4x raised to 4 plus 5x, then we get the derivative of separate. F prime x is equal to, so this one 4, then derivative of this one is just 4x raised to 3 because 4 minus 1 is 3 plus 5x raised to 1 minus 1. So f prime x is equal to 4 times 4 is 16, x raised to 3. Then this is only equal to 1 plus 5. Okay, so maybe we can have another example here. So let's make it more challenging. F of x is equal to negative 9x raised to 5 minus 6x raised to 3 plus 7x minus 7. So we have 4 terms here. So 1, 2, 3, 4. So we get all the derivatives of the 4 terms. So f prime x is equal to, so for this one, so negative 9, then multiplied by 5, x raised to 4, because 5 minus 1 is 4, minus 6 multiplied by, so get the derivative of this, 3x squared, because 3 minus 1 is 2, plus 7x 1 minus 1, and then minus, so the derivative of a constant is 0. So we just simplify this one, f prime x is equal to negative 45 x raised to 4. So this one is minus 18 x squared, so plus 7. So because this one is equal to 1. So this is your final answer. I'm hoping that, for example, y is equal to 5x. The derivative of this is equal to 5 only. So you can shortcut that. For example, f of x equal to 10x. So the derivative of this is just equal to 10. So you can do it like that. So let us go to derivative number 5, the product rule. So for the product rule, we have this formula. So you get the product of uv. So the derivative is equal to u dv over dx plus v du all over dx. For example, so y is equal to um, x squared plus 1, then 2x minus 4. So we treat this as u and we treat this as v. So this is a product of u and v. So we treat this as u and we treat it as v. So y prime is equal to, follow the formula, copy u. U is equal to x squared plus 1. And then derivative of v, dv over dx. Derivative of v is, so this one is 2 minus 0. The derivative of 2x is just 2, and the derivative of negative 4x is 0. Then we put addition sign. So copy v. So our v is 2x minus 4. Then derivative of u. The derivative of u is, so that would be 2x raised to 1 plus 0. Okay? So then we can just simplify. So y prime is equal to, so we just have here x squared plus 1 plus 2x minus 4. So this is your final answer. You can have that as your final answer. So another example, f of x is equal to for x minus 1 and x cubed plus 5. So you treat this as u and you treat this as v. So f prime of x is that formula is copy u for x minus 1, then derivative of v. So the derivative of this is, so 3x squared, then plus 0, plus copy v, so x cubed plus 5, then derivative of u is 4 minus 0. Okay? Therefore, our derivative f prime of x equal to 3x squared, then 4x minus 1 plus 4x cubed plus 5. Okay. So from here, is it clear or you have questions? You can ask question now.
Okay. Sir, so just one question lang.
Mm-mm.
So every time, for example, the y equals x cubed plus 5.
Mm-mm.
So every time, if it's just 5 lang, for example,
Mm-mm.
tawag dito,
Variable.
wala siyang variable, it's automatically constant.
Yes, yes, yes.
Or, okay.
So do you understand the formula for the product rule? Because it could be a handful.
I'm getting it, sir. So basically, to in essence, the product rule is multiplying the derivative of 1 and derivative of 2, so u and v,
Yes,
and then which will be separated.
by a
It will be it will be separated with each other, and then
by a
added
plus
and
sign.
simplified. Yes,
Yeah,
sir.
yeah, yeah. That's nice.
Okay. I get it, naman, sir.
Okay, okay. That's very nice. Because for some
Mm.
first timers of this, because this is maybe a long formula for them, then it is a little difficult. So if you understand it, then it's nice. Okay. So another one is the combination case. For example, you have derivative of u raised to n. Then the derivative is n u n minus 1, then du all over dx. So this is a very similar to the derivative number 2, for example. But in derivative number 2, we have this case, for example, x raised to 6. Then the derivative of this for the derivative number 2 is 6x raised to 5, right? But for the combination case, you have something like this. Y is equal to x 2x plus 1, then raised to 6. So here, you have a more complicated given rather than just x. So therefore, to get the derivative of this, so y prime is equal to, just follow the formula, 6. So this will be u, this one, this, so 2x plus 1, then n minus 1 is equal to 5, then the derivative of u. So the derivative of u is 2 plus 0, because the derivative of 2x is 2, and the derivative of 1 is 0. So y prime is equal to, um, so the 12, 2x plus 1 raised to 5, because 2 times 6 is equal to 12. Let me give you another example. For example, so f of x is equal to um, 2x squared plus 4x raised to 3. So this will be your u. So the derivative of this is, so just bring down 3, 2x squared plus 4x, and then 3 minus 1 is equal to 2, then the derivative of u. the derivative of u is equal to 4x plus 4. So 4x because, um, no, let me slow that one for you. Okay. So the derivative of u is 2, then multiplied by, that would be 2x raised to 1 plus 4. Okay. So we just separate the 2, then the derivative of x squared is 2x raised to 1, then the derivative of 4x equal to 4. So f prime x is equal to 3 2x squared plus 4x squared, then 4x plus 4. Okay, so maybe you can have this as your final answer. We don't mind. But you can simplify that. F prime x equal to, you can multiply this along with the 4x plus 4. So that would be 12x plus 12. Then 2x squared plus 4x squared. So you can also have this as your final answer. Okay? Do you have any question with this?
Sir, can you give me another example on this one?
Sure, sure.
Na medyo nagulan na konti.
Okay, okay.
But I kind of get the idea.
Yeah, sure. Hold on. So let me just erase this one. Okay, so when you are seeing an exponential expression, for example, f of x, maybe 4x raised to 7 plus 6x raised to maybe raised to 9. Okay, so this will be your u. Okay, so it's just like saying this is u raised to 9, something like that, right? Then our f prime of x is equal to, so you just bring down 9, so 9, um, then
Mm.
4x raised to 7 plus 6x. Since this is 9, 9 minus 1 is equal to 8. And then you just add the derivative of this u. So the derivative of u inside the parenthesis is, so 4, then multiplied by 7, x raised to 6 plus 6. Is that clear? And then f
Yes,
prime
sir.
x is equal to 9, 4x raised to 7, excuse me, plus 6x raised to 8. And then just simplify this one. So that would be 28 x raised to 6 plus 6. Maybe you can have this as your final answer. Another,
Sir,
mm-mm.
another question.
Yes.
Oh, wait. I think wait, I forgot it, sir. Huh? So, sir, basically, ano ba ito yung word? The the one on the left, the 9 or x raised to 7 plus 6 over 8. Wait. Okay na, sir. I get it na. Sorry.
Okay. Okay. So maybe you can ask more questions later.
Yes,
Okay.
sir.
So now let us find the derivative of an exponential function. Okay. So we have two types of exponential functions. So the e raised to u and the a raised to u. So let us first discuss the e raised to u. So for example, y is equal to e raised to 4x. So by the way, e is what we call the Euler number. Euler number. So E is called the Euler number. So this is read as Euler, then number.
Euler.
Okay, so if we get the derivative of this, so y prime is equal to, so you just copy the e raised to u. So our u here is equal to 4x. So the derivative is e raised to u, then the u all over dx. So what does that mean? So y prime is equal to, copy the e raised to u, then the derivative of u. U here is 4x. So therefore, the derivative of that is just 4, right? So y prime is equal to 4 e raised to 4x. So another one, uh, y is equal to e raised to x squared, for example, x squared. So our y prime is equal to, so just follow the formula. So copy e raised to x squared. Then the derivative of x squared is equal to just 2x raised to 1. So y prime is equal to 2x e raised to x squared.
Mm.
Is that clear?
Yes, sir.
Okay. So we can go to another exponential function, the a raised to u. So for a raised to u, hold on. Scale. Okay. Excuse me. Okay. So for a raised to u, for example, y, y is equal to 5 raised to 10x. So for the another example, the base is not e anymore. It's just a regular number like 5. So our y prime is equal to, just put ln of 5, and then, I'm sorry, we moved, I think, here. Y is equal to 5 raised to 10x, for example. So y prime here is equal to ln of 5, and then just follow the derivative earlier. So that would be 5 raised to, just copy, 10 raised to x, and then multiplied by the derivative of 10x, which is 10. So your final answer is just that. So 10 ln of 5, then 5 raised to 10x. So you will notice that there's just an addition of this term. So the logarithm of the number, the base. Because, for example, if we follow this one, so y is equal to e raised to 10x. Here, if we follow this one, that would be y is equal to ln of e, then e raised to 10x, then multiplied by 10, right? So the ln of e is just equal to 1. So therefore, you can just write this as 10 e raised to 10x, something like that. Okay, but here ln 5 is not equal to 1, so therefore we just write the longer version of it. Okay, understood?
Yes, sir.
Okay, so for the logarithmic function here, so we have ln of u is equal to 1 over u d over dx. So for example, you have problem ln of 7x. So our u here is the 7x, right? Then our y prime is equal to 1 over u, 1 over 7x, because our u is 7x. Then the derivative of 7x is equal to 7. So therefore, our y prime is equal to 7 all over 7x, or we can cancel the 7, 1 over x only. So another example, f of x is equal to, let us say, ln 3x squared. So our u here is this one. So our f prime of x is equal to 1 all over 3x squared. Then the derivative of 3x squared is equal to 3 multiplied by 2x raised to 1. So our f prime x is equal to 6x all over 3x squared. So we can simplify this one. So 6 over 3 is 2, right? Then x, so we can cancel this one and another here. So that would be x. So your final answer is this one. So did you understand that, the simplification?
So, sir, basically,
Mm-hmm.
whatever is in the parentheses
Mm-hmm.
beside ln, you
Mm-hmm.
will get the reciprocal and then multiply the derivative.
Yeah, that's very good.
Okay, sir.
Okay. Basically, that is the last formula for the slide. But I think I forgot one formula here. The 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 quotient rule. I think I deleted the slide. But let me just add that now. Okay. We have a product formula, product rule earlier, right? So we also have the quotient rule. So the quotient rule um, is something like this. The derivative of u all over v. So now we have u over v is equal to copy v, then derivative of u with respect to x minus copy u, derivative of v all over the derivative in terms of x all over v squared. So it's a lengthy formula, but let me give you an example. For example, y is equal to x plus 2x plus 3 and x squared minus 1. So our u here is the numerator, our v is the denominator. So to follow the formula, copy v. So we will copy the v, x squared minus 1, then derivative of u. The derivative of this is just 2 plus 0, right? And then minus copy u. Your u is the numerator, 2x plus 3, and the derivative of v is 2x minus 0, or minus 0 somehow there, all over v squared. So v squared is copy v, so x squared minus 1 then squared. Okay, so just simplify this one, then you have an answer. So maybe I can put our simplification here. So y prime is equal to 2x squared minus 1, then minus 2x 2x plus 3, oops, all over x squared minus 1, then squared. So this is your final answer. Okay, so maybe I can give you another example. So the formula is the derivative of u all over v is equal to copy v du all over dx minus u dv all over dx all over v squared. Okay. So another example is f of x is equal to x cubed plus 2 all over 4x minus 3. So our u here is the numerator, our v is the denominator. Our our derivative is, so copy v, our v is 4x minus 3, then derivative of u, the numerator, that would be 3x squared. So let me do the shortcut. Minus, copy u, your u is the numerator, x cubed plus 2. Then the derivative of v, denominator, is just 4 minus 0. All over the v squared, so copy v, 4x minus 3, then squared. So our final answer, we can write here, is equal to 3x squared, 4x minus 3, then minus 4x cubed plus 2. So just simplification, all over 4x minus 3, then squared. So this is your final answer for that one. Okay? It was gone. Sorry. Any question?
Not sure lang, sir. Wait lang po.
Sige. You want another example?
Yes, sir. Yes, please. Thank you.
Okay. Hold on. So this is the most difficult formula, I think, in differentiation because it's very lengthy. Another, I will just write the, it helps if you write the formula. So u over v is equal to, so v, so you always start with the denominator. So that's a technique or hint. Then the derivative of u with respect to x minus copy u, derivative of v all over dx all over copy v, then squared only. So for example, we have y is equal to 3x plus 4, then 9x raised to 5 minus 1, for example. Okay. Our u here is the numerator, our v is the denominator. So if we get the y prime or the derivative, then first we copy the v, the denominator, 9x raised to 5 minus 1. And then derivative of u, the derivative of u is the numerator, so that would be just 3, right? Plus
Yes.
0. Okay. So minus copy u, that would be 3x plus 4. And then the derivative of v, our v is the denominator. So that would be 9 multiplied by 5 x raised to 4, because you bring down 5 and then 5 minus 1 is equal to 4. So minus 0 all over v
V
squared.
squared.
Yeah, so that, sorry, I keep clicking the something here in, I cannot undo
Key
that.
bindings.
Yeah, because I'm
Key
using a pen, a stencil, so when I click something here, the text is gone. Hold on.
Yung
Let me do another one.
the key
Derivative.
binding.
Yeah. So u over v. So, but I think you're understanding the concept now. So v du all over dx minus. So you remember the minus here because in the product rule it's plus.
Yes,
Then
sir.
u,
So it's opposite lang.
yeah, and you have the denominator. You have the denominator v squared, right?
Yes, sir.
Like here, v squared. Okay. So let us repeat. For example, I'm having here 4x minus 2, then x raised to 5 plus 1. Okay. Our u here is the numerator, our v is the denominator. Our y prime is equal to, So copy V, our V is x5 plus 1. Then derivative of u. So u is the numerator. So that would be 4 minus 0, right? Minus copy u. So 4x minus 2. And derivative of v is 5x raised to 4 plus 0 all over v squared. So x raised to 5 plus 1, then squared. Then just simplify our y prime. So let me write it here. So 4x5 plus 1 minus 5x raised to 4, 4x minus 2 all over x raised to 5 plus 1 raised to squared. So this is your final answer. You can write it down as your final answer.
Mm.
Your final answer in quotient rule is really long, or it's bigger than the given. So you don't have to worry about that.
Oh, okay, sir. Okay, sir.
Okay, as long as you understand the formula. So eventually, you will get to using the formula. So when you're using it, then because one of the things that you need to learn in differential calculus is there are formulas to be followed. So you need to practice them and memorize them. So if you don't do that, then you will find it hard to get the derivative of some functions.
Oh, okay, sir. Okay, sir.
Okay, so
Question.
yeah,
Can I
sure,
have a question, sir?
sure.
So basically, even though there's a whole number outside, there's no need for it to to distribute it to the other numbers. Okay na siyang ganyan.
For me, yes, but some of the
Ah,
professor will, will tell you to distribute. But for me, as long as the math is correct, then I have no problem.
okay, okay, sir. Thank you.
But there will be some instances in the exam that you will need to simplify. But in the exam, uh, we will try to minimize that by substituting number. For example, let me give you an example. Okay, so in an exam, in our exam, you will notice something like this. Okay. So I will give you a very simple example. Y is equal to 4x squared, 4x cubed rather, plus 9x squared plus 2x minus 4. So when you get the derivative of this, so y prime is equal to 4 multiplied by 3x squared plus 9 multiplied by 2 x raised to 1 plus 2 minus 0, right? So y prime is equal to 12x squared plus 18x plus 2. So if you will be getting the derivative, this is your answer, right? But in the exam, you will be asked what is the value of y prime or the derivative if x is equal to 2, something like that. So you just substitute 2 here. So y prime is equal to 12, 2 raised to 2 plus 18 times 2 plus 2. So is equal to, so 12 times 4 is 48, I think. 48 plus 36 plus 2 is equal to, so 70 plus 16, 86. So your final answer is mostly numbers. Did you understand
Sir,
that?
wait last.
Sure.
Sir, wait last, sir. Para may mali. But,
Alin?
no, it's 48 squared, di ba? Kasi 12 times 2. Wait, 12 times 4. Tama. Okay,
Yeah.
sorry, sorry.
Yeah. Yeah. That's 12 times 4.
Kinabahan ako.
Yeah, yeah. So most of the time, because it's very difficult to give an exam that we differ in simplification, because I can simplify, then you can simplify in a different way. Do you agree with that?
Mm.
Sometimes different simplification is it differs from person to person. For example, 2x 4x plus 1. So I can write it as 4x plus 1, then 2x. But these are the same thing, right?
Yes, sir.
So we avoid that in the exam. So we let you substitute a number so that we can arrive at the same number.
Oh, okay, sir.
Okay? So
Yes, sir.
in the exam, it's mostly like this. You substitute a number. But of course, you have to go through the process of differentiation.
Yes, sir.
Okay. So uh, tomorrow we will also have a virtual class. So just the
Mm.
continuation of this one. So
Ah, okay,
do you
sir.
have
Yes, sir.
any question regarding this lesson?
Just one last question, sir, because I think I
Sure.
understood like a faster way to get the derivative. Ano lang,
Mm-hmm.
sorry. So basically, using the 4x cube example. So
Yeah.
basically, the variable
Mm-mm.
multiplied by the
Constant.
given constant,
Yes.
and then the given constant will be minus 1. So basically 12x
Yeah. So
cube. Okay.
let me highlight that for you because I think you understood it. But when we discuss that, that's the shorter way, right? For example, y is
Yes,
equal
sir.
to 10x raised to 5. So
Mm-hmm.
the derivative of this in a very quick way is 50x raised
50
to 4
x is to
because
4,
you just
yes.
multiply this one and you
With the
subtract 1 in
base.
this, right? So that's very good
Yes,
of you.
sir.
So f of x, for example, is equal to negative 16 times x cubed. So the f prime of here is, so that would be negative, I think, 16 times 3. So 30 plus
48.
48,
48,
yeah,
sir.
okay, 48
Yes.
x squared, something like that, right?
Mm-hmm.
And one more thing you have to remember, if you are given f of x equal to 10x, then your f prime of x is only equal to 10. No need
10.
to no need to go through the long process of differentiation. So
Okay,
if you
sir.
know the concept, then you just write the 10, right?
Mm, yes, sir. And if
Okay.
it's just the base only, it's automatic
Yeah.
0.
Yeah. For
Yay.
example, f of x equal to 10, then f prime of x equals 0. So if it's just a constant, then 0. If it has a variable, then it's
Only
not 0.
one variable.
Yeah,
It's just self.
yeah,
Okay.
something like that.
I understood that, sir. Thank you.
Okay, okay. So I'm hoping that you attend tomorrow and with your other classmates. So I cannot blame them because maybe they can understand it by themselves. So
Yeah. Wait, sir. So
sure.
same time again tomorrow at
Yes,
10 a.m.
yes, 10 a.m.
Okay.
Okay. So it's just for only this week that I will discuss two lessons because next week I will
Mm-hmm.
be only discussing one lesson only. Just the week 9.
Mm-hmm.
Yeah. Because this one
Okay,
is
sir.
week 7, then tomorrow week 8, and then next week just week 9.
Mm-hmm. Okay, sir.
So I'm just trying to catch up with the lesson. So I decided to do two lessons this week.
Okay, sir. Okay, sir.
Okay, so maybe I will be posting this in the LMS for you to, grab it when you need a copy of this. So together with the examples, I apologize for the crude penmanship because I'm just writing through a computer. So, but you
It's
can
okay naman, sir. I
okay,
understand it naman.
okay. So, but maybe I can post it and then but I will hide it first. If you just like to, grab the copy, then just message me in the LMS and then I will show it to you.
Okay, sir.
Okay. Also, I will post the YouTube video of my discussion at YouTube. So if you would like to review some of the discussion I made, then you can go to that link. So that's all for today. So I hope you learned something. Then I will see you again tomorrow.